So this is for homework number 4, the temperature control fan. So what I have here is I have the circuitry, the oscillator, not oscillator, but the optocoupler circuitry and transistor that controls the motor. I have the fan here, same circuitry from last homework with the tachometer. Instead of the power being applied directly to it, I'm now going through this circuitry here. The blue wire is going to the collector of the transistor here, and the red wire is going to the plus of my power supply. The red wire from the power supply goes into the plus rail on the breadboard, on the breadboard, and the orange wire is ground. Sorry, I've been sick for the past few days, so my voice is kind of cracky. Alright, so then the power is coming from this module here. It outputs 12 volts at about 6 amps. So the power supply module supplies is at 12 volts. I know that was a requirement for the homework, so comes in fan. The blue wire here provides both VCC from my board and the signal that I'm using to generate the PWM coming onto the motor control circuitry. The purple wire here, the one right next to this red wire, this purple wire, this guy here is the PWM, and this guy, this red wire, is just VCC coming from the microcontroller. So what I'm showing here is the actual temperature and the RPM of the fan that I'm capturing. So I have FreeRTOS running, and the RPMs is being calculated based on the interrupts that's being generated by the blade of the fan, like the previous homework. And I have another task that's calculating the RPM every minute. So that task pretty much delays for about 60,000 count, and then it wakes up and calculates the RPM and displays it, and then goes back to sleep. The temperature capture task runs every 10 seconds, but the fan task just runs continuously. It doesn't have any time delays on it, but it also has a lower priority in the firmware. Right now it's 77 degrees in my office here, and the RPM's at 2,503. There's a digital clock on the wall here. I mean a digital thermometer here that says 77 also. This is 77. What I'm gonna do is, I have this glass of water here. I'm gonna position the temperature sensor in the water, and the temperature should drop, which will cause a decrease in the RPM count. So the temperature dropped to 69 degrees because I have a temperature sensor in the water. Dropped to 69 degrees. So after about a minute, I should see an updated RPM value, which should be lower than what's being displayed now. It'll take a minute. There's a tachometer circuitry here is what's gonna cause the decrease the it's gonna signal the interrupts, and after a minute the temperature value should change. I mean the RPM value should change. Circuitry that's controlling the fan and the motors. I'm 68 degrees Fahrenheit. That's the temperature of this glass here, and the RPM value is like 2,325. And take it back out. It should jump back to about 78. So I just took it back out, put it on the bench. So as the temperature value increases, the RPM value is sort of increasing as well. So 3. Temperature is now at 76.55 degrees, and the RPM value has jumped up to about where it was when I first started, 2,453. 76 degrees. So we're not quite at room temperature here yet, but the temperature sensor is still a little wet. So yeah, that's homework number 4. I'm gonna keep going here so I can catch up. Alright.